Hello, everyone. I'm back again showing you how to find more information from the Google Classroom website. Remember, to get to this information, please go to your classwork. The resource library has the periodic table that you need. My periodic table that I'm using, I have open in a new tab. You can also find this notes packet in the Unit 5 ionic bonding. You can look for the notes and homework pages 1 through 13. I've also opened this up in a new tab. So far, we've gone through pages 1 and 2, and now I'm going to show you how you can use those charges on the element to figure out how they're going to form an ionic compound. So to do that, first I want to remind you that these elements will form charges because they have dot structures. So to show you what that means, I'm going to insert a drawing to show you what's going on. So first off, we have the element K, potassium, and I'm going to make it bigger. Here's our K, potassium. And we have another element, sulfur. These elements have dot structures. So let me draw some dots on these. I'm going to draw them as little circles. Actually, I'm going to draw them as dots here. So potassium has 1 dot and sulfur has 6 dots, right? Because potassium is in the 1A column and sulfur is in the 6A column. So 1, 2, 3, 4, 5, 6. And what happens is potassium wants to lose that electron and sulfur wants to gain that electron. So what's going to happen is that potassium's electron will go over here and become part of sulfur. But you'll notice that sulfur is still not happy because it has 1 missing electron. So that means we need another, I need just that pointing. We need, whoa, not that one. We need 1 more potassium, another potassium. And that potassium brings with it another 1 electron. And so what happens with that other potassium, now that potassium can give its electron to sulfur. So when we're writing this out in an equation, it means that we need to show that these 2 potassiums are giving their electrons to sulfur. So that means that each potassium is going to get a +1 charge, and that sulfur is going to get a -2 charge because it got 2 extra electrons, 1 from this potassium, 1 from that potassium. So I'm going to save and close this. Unfortunately, the drawings won't show up. So we have K and S. So what does this look like? Come back. So remember, each K is going to get a +1 charge. I'm going to show that as a +1 charge. And each S is going to get a -2 charge because that S got 2 extra electrons, 1 from each K. But each K got a +1 charge because each one lost 1 electron. But notice that we needed 2 potassiums to make sure that S was full. So we need 2 potassiums, 2 +1 charges to balance out that -2 charge. So that means our formula has to take into account we have 2 Ks and 1 S. Don't forget to turn that 2 into a subscript. Subscript means that it's a little one, K2S. All right, so 2 potassiums, 1 sulfur, 2 times +1 is +2. Remember, there's an invisible 1 there. 1 times -2 gives you a -2. So total of -2, total of +2. Now it's balanced out. You can do the same thing for these ones, right? Aluminum is going to get a +3 charge, and chlorine is going to get a -1 charge. Notice that the +3 and the -1 don't balance each other out. We need 3 total negative charges to balance out every 3 positive charges. So now our formula is going to be AlCl3. And that 3 needs to be little on the right-hand side of the arrow, and it needs to be big, however many there are, needs to be big on the left-hand side of the arrow. You'll notice that if you've got the charges right, all you need to do is just move those charges there. Move that charge in the front, right? That 2 tells you to balance it out, you're going to need 2 of these. That 1 tells you you're going to need 1 of those. The same thing happened here. There's a 3 there. Look, there's a 3 there. There's a 1 there. There's an invisible 1 there. Wah, wah, wah. So now I'm going to erase these ones so I can scroll down a little bit. Okay. Calcium is going to have a +2 charge. Phosphorus is going to have a -3 charge. -3 charge. Charge goes in the top right. These two don't balance easily, so we're going to do that switcheroo, right? The 2 is going to go in front of the P, and the 3 is going to go in front of the Ca. So that means we need 3 Cas and 2 Ps, 2 phosphorus. And we're making our formula. Now we have Ca3P2. Again, you need to make those into subscripts. Make them smaller. Make them smaller. You can do that using the format text subscript. Subscript makes it small. Superscript makes it small on the top. Subscript is small on the bottom. Superscript small on the top. Okay. What about when they have polyatomic ions? Where do you find those? That's right, on your periodic table. On the second page of your periodic table, here are your polyatomic ions. OH is right there, and it tells you what the charge is. OH has a -1 charge. So that means we're going to give OH a -1 charge. And Mg you find on the regular part of your periodic table. Mg has a +2 charge. So remember, we're going to share these charges. The 2 goes in front of the OH. The 1 goes in front of the Mg. When we write it over here, MgOH2, some of you ask about parentheses. Because this is a family, OH is a family, we want to put that family in parentheses. Because when we make this into a little 2, if I don't use parentheses, that's telling me I just have 2 of the H, but I want 2 of everything in that family. So give the OH parentheses. Remember, families like to hug. It's especially important now in a time of social distancing. So MgOH2, there are 2 of both of these things. So make sure there are 2 of both of those things in your formula. Figuring out the charges of polyatomic ions, remember, is easy. You can find them on the periodic table. It's right there given to you. Let's take a look at this last one. NH4 has a +1 charge because NH4 is here. Ammonium has a +1 charge. We're going to give our +1 charge here. And S on our periodic table has 6 valence electrons, which means that it wants 2 more -2 charge on our S. All right, these are not balanced. We have 1 of these and 2 of these. We need 2 of these and 1 of these. So now when we're making our formula, NH4, we need 2 of these NH4. So put the family in parentheses, and you can write the S on the outside. NH4, we need 2 of those. Remember to make your 2 little and the 4 also little. Use your subscripts in your text subscript there. All right, NH4 is the family. Keep that family in parentheses and then put the 2 outside because you needed 2 of them. I hope this helps you figure out how to make these equations a little bit easier. Good luck.